Hello, and thanks for joining us. My guest today is Sanjeev Polapaka, Principal Solutions Architect at AWS. Sanjeev, thanks for joining me.
Thank you, Terry. Thanks for having me.
We're going to jump into this topic about AI and architecture. We've seen agencies move from AI pilots to more serious implementation. What would you say is driving that shift?
I mean, it's always been the same. There's always a drive to improve upon the mission, right? They will deliver better solutions to customers. And initially, I mean, the cloud migration was the same story, right? You get more efficiency, the more productivity that you can get with cloud and some of the innovations that you can make. That started driving agencies towards the cloud. Now it's the same story with AI. We're able to see that AI is demonstrating potential benefits in terms of efficiency gains, saving costs, accelerating deployments, and a whole lot of more things that will deliver several benefits to the people. So that's what's got the agencies, starting to work towards these initiatives.
So, as agencies are making this shift, what are some of the lessons learned about scaling AI in a way that's sustainable and secure?
Oh, that's a great question. I mean, basically, there's a lot to that. In terms of scalability, there are so many different aspects of AI, right? I mean, at the heart of all of it is data. Because if you don't have the right data, you're not able to scale the data properly, organize it in a good way, that's going to be a problem. So that they have to make sure that the data is sorted out, well connected, etc. Then if you think about it in several stacks, there's a data layer. Then there's the middle layer. Those are the models. So the foundation models or the large language models or multi-modal large language models, these are the heart of the AI engine currently. So just to give a quick history, uh, we've had AI before, right? And it's been there for quite a long time, but it's been getting a lot of attention recently because of these foundation models. So think of like GPT, ChatGPT is very famous. So they have a foundation model called GPT that started the whole thing. Now AWS has its own offerings. We bring our own models. We also work with partners like Anthropic to get their models and offer it to customers. So that's the second layer. That's the models layer, right? The models access to data. And the models need to scale too. So basically, these are large models. You need to deploy them in a very scalable infrastructure. And that's what we provide as a cloud. We can easily scale up the infrastructure so that when you start using these models, you're able to use different types of models, and you're able to also scale up in terms of the number of questions that you can ask, how often you ask. So there's a lot that is happening at that level. And again, AWS is able to provide that very scalable infrastructure for using or inference of those models. Um, and then on top is the application. The application is like your user interface that calls these models. And that has to scale too, right? You have to deploy those applications as well. And again, using AWS, you can allow you to scale it. So there's a lot of things happening. I still didn't even talk about training these models. The training of these models is a big thing, right? It takes a long time. They use a lot of resources. You can see that there's a lot of effort being put into investments in data centers because not only for inference, which I talked about, where you're calling the model, but also for training the models. And those are to create the next level model, the next level models, which will probably take us to the next step in AI, right? So there's a lot of investment there.
Let's circle back to the data question, because as you say, data is a big concern. It's at the root of the AI deployments. How do you help agencies maintain visibility and governance over their data while they're tapping into the scale and
Mhm.
flexibility that they need?
Yeah. So again, data is everywhere, and it's only growing by the minute and by the second, I would say. Uh, and the most important thing for agencies to understand is that yes, this is a changing environment. It's not a static environment, it's changing. And there used to be this thought process of, hey, I can create this large set of infrastructure or a schema or a collection that can centrally organize and pull all these data and then catalog it. That's been the effort for the last 20 plus years. It's really not going to happen. That's what people are realizing. It's very difficult to do that in this changing environment. So you have to live with the change, and your architecture should be set up so that it's, very fungible, or the ability to absorb changes. And so there's a new architecture where, hey, you don't really try to collect all the data per se, but you start setting, some kind of a link to the data. And you basically say, oh, the data stays in place wherever it is, but I'm able to track it. So I'm able to catalog it wherever it is, and I'm going to be able to see it in a very controlled way. So being able to do that, right? Being able to track the data wherever it is, being able to work with it wherever these data sources are, and fixing it at the data source itself, right? Fixing the problems at the data source, and having some kind of a view or some kind of a intermediate layer there where you can see all these different data and being able to access it, being able to control it, and then being able to federate. That means if there's a data in, let's say, organization A, and there's a data source in organization B, before it was I get A and B into the central place. Now we're saying organizations A data remains where it is, organizations B's data remains where it is. But we give you the central layer where A can say, hey, B, if you want to access my data, this is what you need to do. And they give you the access. B can get access to A's data by doing the same thing. So it's a permissions model, right? And they say, oh, you can access my data, I can access your data. I'll pull what I need, and I'll do what I can, right? And so that's the changing mechanism where you're able to actually not move the data a whole lot, keep it where it is, but still being able to federate or share the data across.
You said some really interesting things there, dealing with data where it is, living in a world that is constantly changing. And a lot of people get very nervous about the security and the sovereignty of their data in that space.
Right.
You talk a little bit more about living it and being flexible, but also then keeping that data wherever it is secure and having a solid governance model around those permissions.
Exactly. Yeah. That's what it is, right? This layer that I was talking about is basically having that governance model, and it's a flexible model where you talk about something like fine-grained access control. That means I can go down to the lowest level in your data, and I can give control the permissions of it. And you set up the infrastructure in such a way that there are some data owners, there are some data SMEs who will be responsible for providing access. So if I want to act like organization B wants access to a certain piece of the data in organization A, there are some stewards, there are some folks who will be able to provide that access. So the mechanism is there, right? There's that layer which says, oh, this person wants access to your data. But then there's an owner who says, okay, I think that this person will not, use this for a nefarious purpose, so I will give them access. And so that whole setup or mechanism is there. And you can share that all in some kind of a catalog fashion. So you can share it so everyone knows, okay, if I need to get to this place, I need to go there. This is the kind of data access I will be able to get, and this is the person who's going to give me access. This is what I need to do. So you kind of set up security that way. And then on top of that, there's data encryption, and there's all kinds of mechanisms like that at the technical layer that will enforce some of these.
And how do you build consensus around those governance models and those rules?
And that's a good point about these kind of mechanisms, is that it's very flexible, and that's key, right? Everybody wants to maintain control over their particular pieces of the puzzle. So before there used to be a big struggle because everybody's trying to get it into the central place, then who really maintains that? Right? There's no one person who can maintain the centralized model because everybody has stakeholders within themselves. So that's why now that you have this kind of federated model, everybody will be having the need or the requirement to access other data sources. So you're collaborating more with each other, and because it benefits almost everyone. So you as a data producer would be beneficial because in some other use case you might become the consumer of data. And so And you start small, right? You in like any other project, start small, start with one or two organizations, build up that consensus, that layer there, permissions model, see how it works, take the lessons learned, then add another organization, then add another organization, so on and so forth. So it kind of grows organically. And those are the kind of models that really work very well, as opposed to like, the big bang method where you're trying to introduce it to the whole organization. Yeah.
So you start small and you train people on the process and you bring more participants into it and you begin to expand the network.
Yeah, exactly. Yeah, exactly.
And what kind of training is especially important as you're building this out?
I mean, this day and age, training is extremely important, right? I mean, there's things happening so quickly. If you don't keep yourself up to date, you might just get out of date. So continuous training, right? That's the thing. We have to keep learning, and agencies. I mean, I've been working in so many agencies. They're doing a great job of that. Like they have, like for webinars, right, within the team, or they'll have lunch and learns, and it's not just the formal training. It's also like being able to sit and ask questions. Collaborate with other people, and so there's also the formal training requirements that people are, should be taking for awareness, but there's also these informal methods which are very, very important.
Sanjeev, in the first half, we were talking about data and managing and governing that data. I want to turn now to a little bit more infrastructure, I think,
Mhm.
and talk about hybrid. Most agencies are working in some kind of hybrid environment now, some systems in the cloud, some on prem. What are the key challenges in extending AI capabilities across those varying operating domains?
Yeah, I mean, so there's a lot. I mean, so there's, if you talk about AI, right, traditional AI, predictive modeling, things like that, those are based on, some models. They're not foundation models. They're like, custom models that were developed for specific use cases. And so they are not that big, they're not that heavy. So they could be deployed at so-called edge where that means, let's say that, for example, CBP, right? They have these deployments at all the airports, right? So the airports need to inspect goods, or you take the border, for example. The border needs to inspect goods when people arrive. And so you have a model that is deployed at that space to detect that, right? And those models are typically lighter because the infrastructure that you have in those kind of remote environments or those kind of places is not that high or not that heavy. So that's why you have lighter models that are deployed there. So the key becomes then being able to use the cloud to train those models and then use the cloud to deploy to those various remote locations. And so the cloud allows you to do that, right? You can train up the model and then you can pinpoint where you need to deploy them, have the centralized deployment architecture, and we have that with Amazon Web Services as well. We have solutions like Greengrass and EKS that you can centralize and deploy these models to these remote locations. And that really is the heart of it. Then collect all the data back. Like once you make the inference, collect the data back, use that for training in the next cycle. Yeah, go ahead.
So you mentioned CBP. Can you tell us a little bit more, like build out that example, I guess. Tell us a little bit more about what it feels like in practice.
Yeah, so like for example, there's a number of different examples. One example is uh, you want to inspect for like let's say cocaine or any of these smuggled goods. People smuggle these across the border, and you have an inference model that is being deployed at those inspection stations to detect whether the car or the vehicle that's coming in and crossing the border contains cocaine or any other illegal substance, meth or whatever, So those are actually models that are deployed to again make America safer, right? Basically, stop those vehicles and then protect them. So those are the kind of. There's also, for example, at the airports, like I said, inspection of goods that are coming in. You want to check if there's firearms, or if there's any other smuggled goods coming in through the airport. Same thing. So there's a lot, and then you can be utilizing it for so many other things like facial recognition, right? If you go into, I think the airports now, they're using facial recognition to authorize you to enter. If you come back from a cruise, I don't need to go through this entire process of filling out my forms. Now it's just facial recognition. All those are AI models that are being deployed at the edge. But again, I need to build that model first. To build that model, I need data. I need to do that using, machine learning techniques, and all that happens on the cloud because it's much faster. You get better instances, meaning you get better infrastructure to scale out. And once I have that, then I can use that presence of the cloud to deploy this at multiple locations, right? So cloud gives you that centralized platform to collect data, to train the models, and then use a very consistent deployment mechanism at various places throughout the US. So that's the example for CBP, but that's being used for a large number of customers for different purposes. Yeah.
That is really helpful and gives me kind of a visual that helps me understand it. But it also leads into my next question, which is this AI solution doesn't exist in a vacuum. It has to integrate with existing infrastructure, orchestration tools. It has to be that facial recognition wisdom that pops up on some other kind of device. So, what
Yeah.
is the key to making that kind of AI and infrastructure integration seamless and easy for the user?
Yeah, that's a great question. There's a lot of different technologies are there. So, for example, let's say there's some data source, or let's say there's a passport data source. It's there. You need to look up the passport data, right? And that's sitting maybe in locked in an agency's infrastructure. That could be on premises. Sometimes it's on premises. Sometimes it's in the cloud, depending on the agency. But then let's say that it's on premises, that means within the agency's infrastructure, and you need to access that. Then there are many ways in which we can integrate with that, right? So for example, in some situations, we deploy software that is like a cloud-based software on premises so that you can quickly access the data. So that's, for example, in AWS, we call them outposts. So you can outpost is like a piece of cloud infrastructure that is deployed on premises. It has the same scalability and benefits as Amazon Web Services cloud, but it's kind of built so that it's kind of close to the or deployed within the infrastructure of the agency. So what that allows you to do is then integrate with these local data sources and then also get the benefit. That is one way. There's other ways where you can have so-called a direct connect, which is a very fast pipe of network throughput. The throughput is really good connection between the data center of the customer and AWS data center. It's a very fast network, and that's custom built so that hey, you can quickly transfer the data. It's milliseconds response, right? So let's say you need data, right, from this customer's repositories, you can get the data pretty fast because of that high network, right, or high throughput of the network. There's other ways to do it as well. You can actually use something called a storage gateway that allows you to share data from on premises. You can use microservices. Sometimes the performance is so good that you don't need to even transfer the data, just keep everything within the customer's repositories. So there's just a lot of different technologies. There's buffers, there's caches that you can get the data, keep it in a cache close to where the customer is, and then the customer operates within that set of data, and then it keeps refreshing in the background, right? So there's a lot of different technologies that you can use to make this happen.
Well, and again, CBP may be a great example for this, but what happens in a denied environment where you're not hooked up to the internet all the time and you don't maybe have access to the cloud?
That's totally fine. I mean, these systems, like we have something called Amazon SageMaker, I'm sorry, Amazon Greengrass. And the Greengrass, what it does for you is it operates on its own, right? And it can work with your current data, which is in that local environment. It doesn't need the internet access. And when it's working and it's able, like it caches the data that it needs, or it gets the data that it needs, as and when you connect to the internet, it will send that data back. So it's not dependent on the connection. It will work on its own, but as and when possible, it'll update the backend. And you can do that with other solutions like Amazon EKS Anywhere. That's another solution that's like a Docker, right? Docker containers, but that's basically gives you this ability to run the software remotely in that local environment. It doesn't need the connection back to the internet, but as and when possible, if there's a connection, then you can do that. That's what happens even like in cruises, right? Or if there's naval commands, right? There's the Navy, which is this is a very big requirement that everything needs to happen within that vessel. But sometimes, as and when they connect back to the, base back home, they will transfer all that data. So that's another example.
So, how do you help agencies think through this mix about where the AI workload lives? Does it live on the device? Does it live in the cloud? Does it live at the edge? How do you help them get the right balance?
It really depends on the use case, right? So there are some use cases where sub-second latency is critical. I mean, I cannot wait at the border for half an hour to get my car through. I need to get through really fast. So in that case, I may not want to take um, a chance that hey the call to the internet is slow or delayed, right? So in those sub-second requirements, latency requirements, then you might want to have the model deployed at the edge and all the surrounding data right there at the edge so that you can give this response, this sub-second or millisecond responses that but in a majority of the cases, you don't need that. The network connection is really strong. You can send the data back to the cloud, get like the model will be in the cloud, and you get responses back. So it really depends a lot about the use case and also conditions, right? If you're underneath the sea in a submarine, then maybe not. If you're in high in an aircraft mode, you maybe not. So depends on the conditions and the use case.
And so, as you think ahead, what is the one emerging capability or trend in AI that you think is going to have the biggest impact on these kinds of government missions?
So everybody's talking about generative AI and agentic AI, and those are really the solutions that's going to take it to the next level. So what I was talking about more was traditional machine learning, predictive modeling. But things are changing. Where I was talking about those custom models deployment, now we're looking at these large language models. These are very big models that can do a lot of different tasks, and they're so good at it that you really don't need to create these small or customized models. The advantage with that is you're saving a lot of resources. You don't have to spend so much time building these models. So it kind of democratizes the training of the models. You have these pre-built or pre-trained models, you call them, that allow you to do these things. And for a majority of the use cases, you really don't need to, like I said, have these inferences taking place at the edge. You can call the cloud for that. Think about your chatbots, or if you go to a website, if you go to Google, for example, now, if you ask a question, it's going to give you a different kind of an answer. Right? It's more kind of interactive. It collects all the information and it gives you the answer. Similarly, within AWS, if you log into our console and if you have questions about, hey, how do I do this in Amazon or within my AWS environment, you have a chatbot that gives you the answer to that. So all these are like technologies that are using this, generative AI foundation models, and those are going to become more prevalent. Then taking it to the next level, we have agentic AI. And agentic AI is nothing but taking these models and constructing a workflow out of it. So basically, what that means is, as opposed to simply relying on these models to answer questions, like, you ask a question and answer the question, you're going to make those models make decisions. So if you have any workflow, think about any workflow, right? If I get, if basically, if let's say I call center, right? If I have a call center, and if I ask a question, and there's three different places I can go for the information. Based on your question, this agent can direct the call to other places. And it's basically, this is the model doing that. So that's where things are going, and that's how it's going to become more predictive. And I mean, basically, that's where we're going with all these different technologies. Yeah.
Well, Sanjeev, this has been a fascinating conversation. Thanks so much for joining me.
Thank you.
Sanjeev Pulapaka, a principal solutions architect at AWS. I'm Terry Gerton, and you're listening to the Federal News Network. For more on this discussion, visit federalnewsnetwork.com and search Thundercat.